Hello everyone, let us now discuss today's LeetCode POTD problem 1769. Minimum number of operations to move all balls to each box. Now, here we are given in the input with nums or the balls where it represents a binary string. This is a string which is given to us, and this string represents either it contains a 0 or a 1, where 1 contains balls, that means 1 contains of balls and 0 contains of empty bag. So this is about the question. Now we are given with this string, and we have either a 0 or a 1, where 1 represent the balls, 0 represent the empty bag. Now we are asked to find the operations where in one operation you can move one ball from a box to an adjacent box. Box I is adjacent to box J if absolute difference of I minus J is 1. Note that after doing so, there may be more than one ball in some boxes. Return an array answer of size n where answer I is the minimum number of operations needed to move all balls to the I box. So let us consider this example where boxes is equal to 110. Now we are given with boxes is equal to 110. So let us take this first bag. Let us take this bag. If you take this bag, you need all other balls into this bag. So there is one ball in this bag. So what I'm gonna do is take this one ball into this bag. Then you need one operation to get all the balls into one bag. So if I get that operation, then I get 100. That means I need only one operation to get all balls into this bag. So let me take this bag, the second bag. Now if I take this second bag, I have one here, I have one here, and I have a 0 here. That means 0 represent an empty bag. This contains a ball. So to get this ball into this bag, I need one operations. If I move this to this bag, then I need just one operation to do so. Now I got one. But let us get to the third, where it is an empty bag. So you got this 0, an empty bag. Now I need all the other balls into this bag. So to do so, you got this one and this is adjacent. So push that into this empty bag. Then it will become 101. That means this represent there is one ball in this bag. So the operations I did till now is 1. But there is another ball in this bag. I need to do some operations to get that into this bag. This the third bag. Now to do so, I need to uh, one operation. I need to do one operation to move this to the next bag. So if I do, then this will become empty. This bag will become empty as we are moving this to the next bag. Now you got one operation. So increase one operation. And even though you didn't get all the balls into the third bag, so let us get this one ball into next bag. So to do that to do that you need one operation. So here it will be 0. As we are moving this one ball to the next bag, it will be an empty bag, and then will move here and it will become 2. So this contains 2 balls. This means bags containing balls. So you got one operation again. So increment by 1 and you get 3. So 1, 1, 3 are the operations to get all balls in each bag. So this is the output. But let us don't waste our time by doing the dry run for 001011. Now let us take that boxes given are 001011. Now let me take one thing. The first thing I'm gonna do is left thing. Left. I take the left. That means here I will take the count of number of ones to the left. So I get here there are no lefts before this index. So I get 0 here. And I get here I am not having any ones in the left. So it is 0. The 1 represent the ball and 0 represent an empty bag. Now I got here, but till here I didn't get any one, any ball. So it will be 0 itself. And you got to this index and you got one ball in the previous. So increment by 1. Now you got this index and till here the count of number of balls previously to the left are 1 and you got to this index till here you have 1 and you have 1, that means increment by 1. So 2 here it is 2 and you get to this index. After that you will be having another we will be taking another index, then you will get 3. That means till this out of index, that means till here you got 3 balls. So this is the left count. But wait, let me calculate the number of right count. That means let me take that. So So I'll be taking the number of balls to the right of index, to the right of index. So I'll be starting from this index. So let me take that index. Let me erase these things. Now you got to this index. So to this index there are no balls initially to the right. So there are no balls initially to the right. Now you got to this index. Now there is only one, but to the right of this index you got one ball. So increment. Now to the right of this index, to the right of this index you got two balls. So here you get a 2. Now now you got at this index. So at this index, the number of balls I have are only 2. So here also I got 2. Now at this index, you got the number of balls to the right are 1, 2 and 3. So here it will be 3 and I got to this index where till here I got just 3. Now, wait a second. Are we asked for number of balls? No, we are not asked for the number of balls. We need the count to get all balls to a to an index. Now you need this count. But wait, here there is only one ball, and to get this ball into this empty bag you got 1. There is only one operation to get that one ball into this bag. But to get this ball into this index you need 2. You need 2. That means you need the count of 2 to get this ball, all the left balls into this index. That is the thing which I want to convey to you. We need the count to get all balls to the left into the current index. So this is the thing you need to get. We need the count to get all balls to the left into the current index. So till here you got 2. So let me take this 2 and you got this. 1 minute. Till here you need 2. But wait, you got a 2 here. This is the count of balls to the left. To the left you got only 2 balls. But the operations which you need is for this ball, you need 1, 2, 3. And for this ball you need 1 operation. That means 3 and 1 will become 4 here. 1 minute. So to do these operations you need 4 operations to get these 2 balls into this index. So but do you need this another index? Absolutely no. Out of bounds, you don't need this. So you have one ball, 1 operations to get all the balls to the left to this index. You need just 2 operations to get all the balls to the left to get to this index, and you need 4 operations, 3 for this ball and 1 for this ball. I think it's clear for you. This is for left. But what we are doing here, initially we got a 1. Initially it is 1 here. It represents the number of balls to the left. Initially it is 2 here. If you remember, it is 2. But here you added 1 to this one and you got, is it or not? That means we are counting the number of operations to get all the balls to the current index. So you got this 2, and let me drag this here. You got this 2, and here you got a 2. So the number of balls to the left of this index is 2, and the number of operations to get all the ones till here, till this index. So till this index it is 2, but till this index you need to add the number of balls and the number of operations. So for this index you got the operations just 2, you get this. And for this, still you got only the number of ones to the left, the number of balls to the left. If you add, you already got the number of ones, but if you add previously got number of operations, that means this 2 to this 2. So if you do that, 1 minute, if you do that, you will get a 4 here. That's why you need 4 operations to get all the balls to the left to the index. Now, is it same to the right balls? Yes, absolutely. If you add 1 to 2, it will get 3. And if you add 3 to 2, it it will get 5. If you add 5 to 8, it will get, sorry, 5 to 3, it will get 8. And if you add 8 to 3, it will get 11. So simply I need to add these two. So let me write that 11, 11, and here 8, and here 5, here 4, and here 3, and here 4. See, we have solved this without giving any explanation, without getting any explanation from the description. 11, 8, 5, 4, 3, 4. Absolutely simple. Now, let me write the algorithm. First thing what we need to do is algorithm, and then we will go to the code. So, let me write the algorithm. 1 minute. The first thing which I gonna do is, the first thing is initialize left count and right count, and I need to construct these arrays. So how I'm gonna do that? I'll be iterating these boxes and increment the left by left count of I minus 1, and will do right by incrementing right count of I plus 1. So that's it, and I'll be writing the code without wasting your time. int n is equal to boxes dot size vector int, we need left count n comma 0 and right count n comma 0, and for int I is equal to 0, sorry, I is equal to 1, I is less than n, and the count is 0, then I is less than n, I plus plus, if boxes of I minus 1 is equal to 1, then increment our count, and left count of I is equal to left count of I minus 1 plus count. So now I is equal to n minus 2 and count is 0. I is greater than or is equal to 0 and I minus minus. If boxes of I plus 1 is equal to 1, then increment our count, and the right count of I is I plus 1 plus count. Then we'll be initializing the answer, sorry, n comma 0. So if you like my explanation, please like this video, share to your friends, and subscribe to my channel. Thank you.